In this video, we are going to learn about scale diagrams and enlargements. So first of all, what is an enlargement? Well, enlargement is when we increase something in size, volume, or quantity. The scale factors of enlargements are greater than 1. Next, what is a reduction? We're going to be looking at reductions more in the next video, but a reduction is making a specific thing or object smaller or less in amount, degree, or size. Scale factors of reductions are greater than 0 but less than 1. So often you'll get fractions or decimals for reductions. Now we have to know what is a scale diagram. Well, a scale diagram is an enlargement or a reduction of another object or diagram. So in my definition for enlargement and the definition for reduction, you heard me talk about scale factor. Well, what is the scale factor? The scale factor is the ratio of corresponding dimensions of two similar shapes. So now, how is the scale factor of a reduction compared to an enlargement different? I want you to pause the video and see if you could figure this out. So let's see if you're right. A scale factor for enlargement must be greater than 1. Now, a scale factor for reduction must be less than 1 but greater than 0. So let's see what this looks like. If I was to have a number line, and I'm going to put right here 0, and here I'm going to have 1. So I'm going to say my red is going to be my reduction. So my reduction must be less than 1. So it cannot equal to, so I'm going to have an open circle. And it has to be greater than 0, but not equal, so open circle. Now, let's maybe do green as my enlargement. So my enlargement, once again, open circle, and it's everything bigger than 1. So now we're going to learn about the general formula for scale factor. This formula you're going to be using quite extensively in the next few videos. So then all that a scale factor really is the new image divided by my real image. So now here it says if the scale factor is greater than 1, then it is a what? Well, in order for me to get something greater than 1, that must mean my numerator must be bigger than my denominator. So my image must be bigger than my real life object. That must mean my image is a enlargement. Now, if the scale factor is between 1 and 0, then it must be a reduction. And that makes sense because that means my image is smaller than my real life object. Now, if we think of this, this is also why we can't have a negative. Because none of these, my image or real life, are going to have a negative measurement. So then if the scale factor is between 0 and 1, it is a reduction. So now, if the scale factor is exactly 1, then what happens? Well, then my image equals my real life image. There is no change in size. In that case, the image is congruent. So now, how do we determine the scale factor? So here's my original. It says right there, and here's my new. What is the scale factor of the reduction below? We know it's a reduction because my original is bigger than my new. So my denominator is bigger than my numerator, therefore we know it's going to be between 0 and 1, which means it is a reduction. Now, we look at this here, we have to figure out what is the size of my new. 1, 2 that way, and this is going to be 1, 2, 3, 4. So it is the same as 2 over 4, which is the same as 1 over 2, or we could say 0.5 is going to be my scale factor. Let's take a look at my second example. It wants the scale factor for the reduction from the original to the copy. So here's my original, and this must be my copy. I want to know what is my scale factor of the reduction. So once again, I have to take one side of the dimension. So I'm going to go 20 and 15. So my scale factor is equal to my new divided by original, which is equal to 15, which is my new, divided by my 20, which is the same as 3 over 4. So my scale factor is equal to 0.75, or 3 over 4. So now a key thing for enlargements and reductions is something called proportionality. When we enlarge or reduce an image by scale factor, all the sides of the enlargement or reduction will have the same scale factor. This means that all sides must be proportional. So let's take an example here. I have my original on the left, and I have my new image on the right. Let's see if they are proportional. So I'm going to label this side here A, and that must mean this side here is A. This side is B, this side here is B. And for my image, I'm going to put these little primes by them, those little ticks. So for proportionality, we're saying my new, which is A prime, over my original, A must be equal to B prime, my new, divided by my original. So in this case, my A prime is 10, and my A is 5. Now, is that equal to my B side? Well, we have 12 over 6. So then I end up getting 2 is equal to 2. So in this case, proportionality is conserved among the scale factors. So we have a scale factor is equal to 2, and proportionality, as we showed there, is conserved. So now let's look at my second example. Here, my original is on the right. So I'm going to label each side. We have A and B. Now, in my image, we're going to put that little tick by it too, so we're going to have A prime. This is the short side, which will line up with the A in the original, and this is going to be my B prime. The long side, that lines up with the B in the original. So once again, we have to see if these are proportional. So we're going to go my new divided by my original must be equal to my new divided by my original. We're going to make sure all sides are proportional. Now, we have here A prime is equal to 1. So my new is equal to 1, and we have 2 for my original. Let's take a look at my B. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. And here we're going to have 1, 2, 3, 4. 4. Now, is 1/2 and 1/4 the same? Yes, they are. They have the same proportionality because we look at this. I just multiply this by 4, multiply this by 4. They're going to be the same. They're the same ratio. So proportionality is the same. And my scale factor is equal to 1 over 2, or 0.5, because 4 out of 8 is 1 over 2, or 0.5. So in our last example, we're going to create an enlargement, and we're going to use a scale factor of 3 over 2. Now remember, proportionality means we must multiply every side by 3 over 2. So looking at my first side here, I have a distance of 1, 2, 3, 4. So I'm going to have to go 4 multiplied by 3 over 2, which is going to give me a total of 6. So if I'm going to make a new shape, I'm going to go down 6. So I'm going to go down 1, 2, 3, 4, 5, 6. Now, let's try this top piece here. That's 1. So we're going 1 times 3 over 2 is 1.5. So in the top one, I'm going to have to go over 1.5. So I'm going to go 1.5. Now we're going to try this line here. We have 1, 2. So we're going to go 2 times 3 over 2. This is going to give me a total of 3. So I'm going to go down 3. Next, we have another 1 right here, so I'm going to have to go over 1.5, as we already learned that proportionality. So I'm going to go over 1.5. Then I look at it and I'm going to go down 2. 1, 2. Or we already done 2. 2 is 3. So we have that proportionality of 3, so I'm going to go down 3. And then last, we have 2 again, and let's see if we match up, and we did it right. I have 1, 2. Well, that means 2, we have to go over 3. And let's see if we go over 3 and we match. I go over 1, 2, 3. So it works out perfectly, and that's how we draw a scale factor.